In this example, we have an angle theta, which is going to reside in the first quadrant, and we know that the cosecant of theta is going to be the square root of 10. So based on this information, we're going to be looking for these two values, cosine of 2 theta and cotangent of 2 theta. If you'd like to try these first, go ahead and pause the video and do so, and then come on back and we'll work them together. Alright, so the first thing we need to do with this angle theta is to go ahead and build ourselves a nice reference triangle. It'll be a right triangle, and we'll put theta down here as one of these acute angles in the lower corner. And so we know the cosecant of theta is the square root of 10, or the square root of 10 over 1. And so cosecant is actually going to be the reciprocal function for sine. So sine we know is opposite over hypotenuse. So the reciprocal will then be the hypotenuse over the opposite. So what we can say then is the hypotenuse is the square root of 10 and the opposite is 1. So then we can use the Pythagorean theorem to go ahead and find the length of this other leg, or this third missing side here. So the square root of 10 squared is just 10, and then 1 squared is 1. So 10 minus 1 is 9, and then the square root of 9 is 3. So that value is actually quite nice. Okay, so let's go ahead now and look at the cosine of 2 theta. And we have a nice double angle identity that we can use for cosine. There's actually a few to choose from. I'm just going to go ahead and use the cosine squared theta minus the sine squared theta. And so what this tells us we need is a couple values, one for cosine, one for sine. We're going to get them and then we're going to square them and subtract. So cosine of theta. Well, here's our theta. Cosine is adjacent over hypotenuse. So this will be 3 over the square root of 10, and we're going to square that. And from that, we will subtract, well, sine of theta squared. So the sine is opposite over hypotenuse, so 1 over the square root of 10, and we'll square that as well. So what we see is 3 squared is 9 over, and the square root squared will just give me 10. Minus 1 squared is 1 over that 10 again. We already have common denominators, which is great. So 9 minus 1 is 8 over 10, which I can reduce to 4/5. So this first value for my double angle for cosine, based on this information I was given about theta at the beginning, is going to be 4/5. Okay, so the other value I'm going to look for is the cotangent of 2 theta. Go ahead and write that down here. So the cotangent of 2 theta. Remember, cotangent is going to be a nice reciprocal function. It's really 1 over the tangent of 2 theta. So kind of keep that in mind, reciprocal function. So what is going to be a double angle identity for tangents? Let's go ahead and write that down over here. We can look at it real quick. So a double angle identity for tangent, we've got a few of these as well. One of them is 2 over, and we have cotangent of theta minus tangent of theta. Okay, but remember, we're doing the reciprocal function here, so we're doing cotangent instead of tangent. So we'll just take this thing, and how about we just flip it over? So what we're really looking for is the cotangent of theta minus the tangent of theta, and whatever we get there, we're just going to cut in half. So let's go ahead and use our reference triangle and find values for cotangent and tangent. Okay, so tangent from our theta is opposite over adjacent, so it's going to be 1/3. And if tangent is 1/3, cotangent will be the reciprocal, so 3 over 1. Okay, so cotangent was 3 minus tangent, which is 1/3, and all that's over 2. So really all we have to do now is just go ahead and simplify this. So 3 could be rewritten with a common denominator here as 9 over 3 minus 1 over 3, and all that is over 2, or 2 over 1. So 9 minus 1 is 8 over 3, with that 2 over 1 in the denominator. Remember, these complex fractions are really concerning themselves with multiplying by the reciprocal. So let's multiply by this reciprocal. So that's what we have. And between the 8 and the 2, we can do a little reduction here. So 4 and 1. And what it looks like we have then will be 4/3. So, given this initial information, we knew that the cosecant of theta was the square root of 10, and we knew it resided in the first quadrant. So we were able to find a couple of values, the cosine of 2 theta and the cotangent of 2 theta. And so we found the cosine of 2 theta using this nice double angle identity for cosine. And we were able to find the cotangent of 2 theta by doing the reciprocal of the double angle identity for tangent and then plugging our values in. So we had 4/5 and 4/3 respectively.